Hi Year 7, welcome back to Mathematics for your video lesson today. We're starting off with some flashback questions from concepts we have already studied in class. I'd like you to pause the video and draw these three shapes for me and see if you can figure out the unknown letters. So we're using the fact that the angle sum of any triangle is 180 degrees. And as we looked at, the angle sum of any quadrilateral, any four-sided shape, is 360 degrees. See if you can figure them out. All right, so well done for the first one if you got the value of r being 130, because if we do 20 plus 30, we make 50, and so we've got 130 left to add up to 180. Or if you wanted to, you could have worked backwards and you could have done 180, take away 20, take away 30, if you prefer. Similar logic for the one in the middle. We are trying to figure out what x is that adds with 85, 75, and 110 to make 360. Well done if you got the answer of 90 degrees. So 85 plus 75 is going to get us 160. And then if we add the 110, we're going to get 270. And then we've got 90 degrees left to add up to 360. Or like I said, you could work backwards and you could do 360, subtracting these three numbers. And for the one on the end, we have a triangle with all three sides of equal length. We call that an equilateral triangle. So that tells us that the value of y is going to be the same thing as this side here, which is 3. So we get y is 3. And now we know that because all the side lengths are the same, we also know all the angles are going to be the same. So if we do 180 and we divide it by 3, so we split it into 3 equal parts, we get an answer of 60. So awesome work if you got those all by yourself. For today's lesson, we are finished with 2D shapes and we're looking at 3D solids. So today's heading is prisms, pyramids, and nets. We're going to look at all three today. Okay, starting off with some 3D solids, and we're going to talk about the difference between a prism and a pyramid. So on the left here, we have what's known as a rectangular prism. The reason we know it's a prism is because it's the same shape. It's a rectangle the whole way through. It's kind of like a bread loaf is how I think about it. Anywhere you cut along this block, and if you open it up, you are going to see a rectangle. So that shape that is the same shape, the whole way through, we call that the cross section or the face. So this would be a rectangular prism. And on the right here, we have a rectangular pyramid because the base area, we can see we've got different side lengths, so it's a rectangle. They all meet up at a point and it looks like a pyramid, and that's what we call it, a pyramid. So we got a rectangular prism and a rectangular pyramid. Don't have to sketch these yet. We're going to draw some sketches later on in the video. Okay, another pair. Here we have a triangular prism and a triangular pyramid. Again, we have a triangular face and it's the same shape the whole way through. Or another way you can think of it is you've got two triangles at the front and back, and they're joined by rectangular faces. So on the left we have a prism, and here we have a pyramid because we're meeting up at a point or an apex, and the face on the base is a triangle, so it's a triangular pyramid. All right, we're going to do a quick activity now, which works a bit better in a classroom, but we're going to see how we go. It's a very simple game. It's just called pyramid, prism, or neither. I'm going to put a picture up on the screen and I want you to think to yourself, or if you have someone at home that you can play with, you want to decide whether the thing is a pyramid or is it a prism or is it neither. All right, so here's our first one. Is that a pyramid or a prism or neither? If you are saying prism right now, you are correct. That is a square prism, or we also sometimes call that a cube. Or if you want to be really fancy, you could actually call it a hexahedron. Is another name for a cube, which no one ever uses because it sounds confusing. Here's our next one. What's your pick? Prism, pyramid, or neither? That is indeed a pyramid. We have a square base, so we call it a square pyramid. Up next, is that a pyramid or a prism, or is it neither? Well, this is not a 3D solid. This is a 2D shape, so it can't be a prism or a pyramid because they are both 3D solids. This one is a 2D shape. It's an isosceles triangle, so it is neither a prism or a pyramid. Okay, up next, what is your pick? Prism or pyramid? If you are saying prism, you are correct. We saw that one earlier in the video. This is a triangular faced prism. Okay, next one. We've got a party hat. Is that a prism or a pyramid or neither? This one is a bit of a trick question because it definitely kind of looks like a pyramid because we've got a shape on the bottom and then the edges are meeting at a point. So you could think of this as a circular based pyramid. However, unfortunately, the definitions of prisms and pyramids are shapes with only flat surfaces. So because this cone has a curved surface, it is technically not considered to be a pyramid. So it gets its own name and it is neither. But if you said pyramid, that's all right because it kind of looks like a pyramid and all the rules for pyramids kind of work as well. Up next, we have two circles joined by a tube called a cylinder. Is this a prism, a pyramid, or is it neither? Again, it kind of looks like a prism because we've got two of the same shape joined by what essentially is a rectangle. But again, because this surface in the middle is curved, it is not classified as a prism. So again, this one is neither. It's just called a cylinder. Okay, next one. What is your pick? If you are saying pyramid right now, you are correct. That is a pentagonal base pyramid. 1, 2, 3, 4, 5 sides, and then meeting up to a point. What about this one? If you are saying prism, you are correct indeed. We've got 1, 2, 3, 4, 5, 6 edges on the face. So this is a hexagonal based prism or just a hexagonal prism. Okay, what about this one? What do you reckon? Pyramid or prism? This is indeed another triangular based prism. We have two triangles joined by rectangles. Anywhere you cut it, you are going to see a triangle. This is a prism. And one more. This is called the Louvre Museum. It's in Paris, which hopefully you'll be able to visit one day. And this is, of course, a square pyramid because we see the point up there. All right, moving on now, we're going to look at a cool little pattern in mathematics. This is called Eulers Formula. That's how you say that name right there, Euler. He's a really, really famous mathematician who discovered lots of mathematical things back in the day when he was alive a few hundred years ago. So for your notes today, I'd like you to have a go at drawing these three shapes. Good luck with the pentagonal prism down here. This one's a bit tricky, but the cube and the triangular base pyramid shouldn't be too stressful. Once you've drawn those three shapes, I want you to write next to them how many faces they each have, how many vertices they have, and now when I say vertice, or vertex, pardon me, vertices are just the corners, so the pointy bits. Okay, so vertices are corners. And I want you to write the number of edges, and these are going to be represented by F, V, and E. And then when you've done those, I want you to figure out the answer to number of faces plus vertices minus edges. So go ahead and pause the video and have a go at that for yourself before I spoil it for you. Okay, so for the cube up here, we can see it's got 1, 2, 3, 4, 5, 6 faces. We've got 6 square faces. Number of vertices, we've got 4 corners at the front and 4 corners at the back. So we have 8 vertices. Number of edges, we've got 4 on the front face, we've got 4 on the back face, and we've got 4 joining them. So 4 plus 4 plus 4 would be 12 edges. Now if we do F plus V, 6 plus 8, and then we get 14, if we take away 12, we get an answer of 2. Okay, so 6 plus 8 is 14, take away 12 is 2. Okay, now we'll do the triangular base pyramid over here. So number of faces, we can see we have 4 triangular faces. For our vertices, we have the point up here and 3 on the bottom, so we have 4 vertices. For number of edges, we have 3 on the base and then 3 leading up to the point, so we have 6 edges. Now if we do F plus V, take away E, we're going to do 4 plus 4 is 8. Take away 6 gets us an answer of 2 again. What a spooky coincidence. And now for the tough one, we've got the pentagonal face prism down the bottom here. For our number of faces, we have a pentagon on the front and back, so we've got 2. And then we have 5 rectangles joining them. So we have 7 faces in total for this red shape. Number of vertices, we have 5 corners at the front and we've got 5 corners at the back. So we have a total of 10 vertices. For our edges, we have 5 on the front pentagon, we have 5 on the back pentagon, so we got 10, and then we have 1, 2, 3, 4, 5 joining them. So we have 15 edges all in total. Now to finish off, we're going to do f plus v minus e once more. 7 plus 10 is 17. Take away 15. What do you know? We get an answer of 2 once again. So a few hundred years ago, a very smart man called Leonard Euler figured out that for any 3D shape with flat edges, flat faces, so any prism or pyramid that looks like this or any other shape, if you do the number of faces plus the number of vertices and then you subtract the number of edges, you're always going to get the same answer. You always get 2. And so we called that Eulers Formula, and we still study it to this day. So it's just a cool pattern, basically. And to finish off for today's lesson, our last concept we're looking at is what's called the net of a 3D solid. So a net of a solid is a two-dimensional representation of the faces of a 3D solid. It's kind of like what you would see if you unfolded a 3D shape. So here's an example of a net. Can you think, or can you visualize what 3D solid I have unfolded to be looking at these 6 faces right here? If you're thinking that if you folded these back up, you would be looking at a cube, you are correct. If we folded them back up, it'd make this shape right here, which is a square prism, also known as a cube. What about this one? What do you think would happen if we folded up the triangles on the edges here and they met at a point? What would that shape, what would it look like, and what would it be called? If you're thinking we'd be looking at a hexagonal pyramid that would look like this, you are correct. If we fold the triangles up, they're going to meet at this point up here, and the base is a hexagon, so it's a hexagonal based pyramid. What about this next one? If we folded these shapes up together and we turned it into a 3D solid, what are you going to be looking at? If you are thinking we are going to be seeing a pentagonal based prism, which looks something like this, you are correct as well. So we've got the pentagonal base, we've got the rectangles joining them, so we have a prism shape. And for the last one, bit of a trick one, if we could link these together or fold them up and make a 3D solid, what would that be looking like? This one's a little bit trickier. If we fold the circles up and then we roll this rectangle around to make a sort of curved tube, what you're going to be looking at is a cylinder. So this is actually the unfolded version of a 3D cylinder. So this rectangle here wraps around to make a cylindrical curved part, whatever you want to call it. Okay, to finish off the lesson, here are 3 3D solids. We have a square base pyramid. We've got a triangular base. We have a square base pyramid. We have a triangular base prism, and we have a triangular base pyramid on the end here. To finish off your notes, I want you to have a go at sketching these 3 solids, and then underneath your sketches, I want you to draw what the nets of these solids would look like. What would you be looking at if we unfolded the faces and had a 2D diagram? See how you go. That's the end of today's lesson. So thanks so much if you watched all of that. I'll see you in the next video.